Hello, I am Sunita. Welcome to my class. Here I am going to discuss GBSTR science topics according to the syllabus. Here the topic is friction. Let us discuss the topic in detail. Let us discuss what is friction. When we throw a ball on the floor, it starts moving with same velocity, but ideally no force should be acting in the direction of motion, and according to Newton's first law, the ball should keep rolling, but does not happen. Instead, the ball stops after moving a certain distance. So for a force must be acting on it. We call this force as a frictional force. Consider a ball, throw the ball on the floor, then the ball it will travel some distance on the floor. After covering some distance, later it will stop. According to Newton's first law of motion, the ball it will be in a state of continuous motion, but this it will not happen after traveling some distance. Otherwise, after covering some distance, the ball it will stop because of the opposing force. That force we will call it as a frictional force, or that one we will call it as a friction. What is friction? Friction is defined as the resistance offered by the surface that are in contact when they move over each other. Friction is nothing but a opposing force. It will be act on the body when the body is in motion. This is the opposing force. Always it will act opposite to the direction of the applied force. Let us discuss in detail about a frictional force. Consider two type of surface here. One is rough surface, another one is smooth surface. Then here keep one loaded wooden box on both the surface. In which surface easily you can push the wooden box, whether it is a smooth surface or it is a rough surface. Normally you know on the smooth plain surface easily you can push the wooden box. Why this happens, let us discuss in detail here. Here smooth surface it will act less friction, and rough surface it will gives more friction. Here this girl she is applying a force on the wooden box. The wooden box it will move in this direction. Then the frictional force it will act opposite to the applied force. On the smooth surface the wooden box it will be moved very easily because of the less friction. Coming to the rough surface, here also this girl she is applying a force on the wooden box. Then this box it will move in this direction, and the frictional force it will be acts in the opposite direction. Here the frictional force is more compared to this smooth surface. Therefore this wooden box it will move very slowly. Otherwise in this case it is very difficult to push the wooden box because of the more friction. Then on the smooth surface you can push because of the less friction. Here force exerting body is this girl. She is applying a force on the wooden box, then this wooden box body on which the action is happening. Then here this frictional force we will consider as a contact force, because you can see this wooden box it will be contact with a smooth plain surface. They are touching each other. This type of force we will call it as a contact force. Consider one more activity here. Keep one book on the table. Push the book. Then that book it will travel some distance. Later it will stop. Here pushing you are applying a force on the book. Then the book it will travel in the direction of the force, then stop after some distance. Then why it will stop after some distance? Because of the frictional force. Frictional force is the opposing force. It will act in the opposite direction of the applied force. Otherwise opposite direction of the motion of the body. Is there some kind of force that opposes the motion of load or book on the surface? Yes, that is the frictional force. Frictional force is nothing but a opposing force. It will restrict the motion of the body. Consider one more smooth surface. Spread water on the smooth surface. Then because of the less frictional force, this boy if you want to walk on the surface he will fall down because of the less frictional force. Here the frictional force it will act between the shoe and the surface of water. because of less friction he is unable to walk, he will fall down. Then here frictional force is nothing but a opposing force. It will act on the opposing direction of the applied force. Dependency of friction. Let us discuss in detail how the frictional force it will depends upon the nature of surface. Let us perform an activity here. Procedure: draw line on board with pen or pencil and place it inclined on smooth surface. Then using pen or pencil draw a line on the board which inclined on the smooth surface. This surface is the smooth surface. Next one, now allow pencil cell to move down from the marked line. Allow a pencil cell to move down from a marked line. Then how far does it move? You have to record how far the pencil cell it will move in the first case. Consider this as the first case. Now second one. Now the second case, now spread a piece of cloth over table keeping no wrinkles in the cloth. Now you have to spread a piece of cloth on the table without no wrinkles in the cloth. Now allow a same pencil cell to move down from a marked line. Then here also that pencil cell it will move some distance. Then after it will stop. Consider this as a second case. Then compare distance covered by the pencil cell. Then here the case first, here the case second. Here compare how much distance the pencil cell it is covered. Then observation, you can observe the pencil cell covering different distance on different surface. Yes, easily you can observe. In the first case the pencil cell it will cover more distance, this much the distance. In the second case the pencil cell it covers only a small distance. You can see the difference, which means the friction offered in the second case is higher than the first case. From this you can conclude friction offered in the second case is higher than the first case. Otherwise first case you consider as a smooth surface, therefore on the smooth surface the friction it will be less. In the second case we consider the cloth is offering more friction, therefore in the second case the frictional force it will be more. From this you can conclude friction it will be depends upon the nature of surface. When you are having less friction then it will cover more distance. When you are having more friction then it will cover less distance. Consider two surfaces here. One is smooth surface, another one is rough surface. On the smooth surface, easily you can push the load. On the rough surface, it is very difficult to push the load on the rough surface. What is the reason why this will happen? Let us discuss in detail here. Every surface has irregularities on its surface. Here on the smooth surface, irregularities it will be less. On the rough surface, irregularities it will be more. When the object when comes in contact with any surface, because of the irregularities it will get interlock. The object surface also it has some irregularities, and even the surface also it has some irregularities. Both when they will be contact with each other then they will get interlock. In the case of a smooth surface, because of the less irregularities, this object irregularities also it will be come in contact with this surface irregularity, then both they will get interlock. But here because of the less interlocking, if you apply a less force only it will start moving, therefore frictional force it will be less. If you apply a less force only, that interlock it will get lost. Because of the interlocking loss, that object it will start moving because of the less friction. But in the case of a rough surface, you are having more irregularities. When the object when come in contact with this irregularities, then it will get interlocking it will be more. Then here if you want to make the object to move, you have to apply a more force. Sometimes if you apply more force also, that object it will not at all move because of the strong interlocking. This one we will call it as a greater frictional force. Here you have one thing you have to remember. Frictional force, it will be depends upon the interlocking. If the interlocking is less, you are feeling less friction. If the interlocking is more, you will feel great friction. Dependency of frictional force. Second dependency, extent to which the surface are pressed upon each other. Consider two boxes here. One is empty box, another one is weighted box. Displacing empty box is very easy compared to the weighted box because of the higher friction. Let us discuss here in detail. Already you know, when two surfaces, when they will be contact with each other, then they will get interlocked due to the presence of irregularities of surface and also object surface. Here in this case, if you are having a weighted box, then because when the two surface, when they will be contact with each other, because of the weight, the surface are strongly pressed. If the surface are strongly pressed, then higher interlocking or interlocking will be more, then it will cause more friction. If the friction is more, means you have to apply more force to displace the box. That is the reason the weighted box, it will cause more friction. Due to the presence of higher interlocking, it will cause more friction. Consider next one. Force needed to start moving an object from rest is greater than force required to keep it moving. Already you know, when the object when comes in contact with the surface, it will possess a frictional force. Then when the object is at rest, it will possess higher frictional force, because when the object is at rest, the interlocking between the surface and object, it will be more. When the interlocking is more, then frictional force, it will be more. Therefore, you have to apply more pressure to break that interlock. Then here, therefore, when the object is at rest, you need more force to make the object to move. In the second case, when the object is already in moving, then you have to apply a less force to make the object, it will be in continuous motion, because the frictional force, it will be less, because it will not get more time to interlock again. Interlock between the surface and object, it will be less, because it will not get more time to interlock again, as it is at the rest position. Interlock, it will be less. Therefore, if you apply a less force only, the object, it will be in continuous motion. Friction force, you are having two types. One is static friction, another one is sliding friction. When the object is at rest, then it will possess static friction. When the object is in motion, it will possess sliding friction. When the object is at rest, you make the object to move, then you have to apply a more force. Already you know, because when the object is at rest, the interlocking between the surface, it will be more. To overcome that, otherwise to break that interlocking, you need more force. In the case of a sliding friction, already the object, it will be moving. To make the object to move, you have to apply a less force, because here there is no time to interlock between the surface again. Therefore, you have to apply a less force. Therefore, static friction is more compared to sliding friction. Then next one, let us discuss what is the cause of the friction. Friction is caused due to the irregularities on two surfaces in contact. Already you know, when two surfaces, when they will be contact with each other, because of the irregularities, it will cause a friction. So when one object moves over the other, these irregularities on the surface get entangled, giving rise to friction. The more the roughness, the more irregularities, and more significant will be the friction. As the roughness increases, then it will increase the irregularities also. If irregularities, it will be more, then more interlocking between the surface, it will takes place, then more friction. Types of friction. Following are the friction types, which depends upon the types of motion. First one is static friction, second one is sliding friction, third one is rolling friction, fourth one is fluid friction. Let us discuss one by one in detail. Let us discuss first one, static friction. Static friction is defined as the frictional force that acts between the surface when they are at rest with respect to each other. Here consider an object. If you keep the object on the surface, this surface then the object surface, both they will be contact with each other. Here the object, it is not at all moving, it will be at rest. At rest it will possess a friction. That friction we will call it as a static friction. The static friction, it will be in this direction. Here no motion of the object it will takes place. The magnitude of the static friction is equal in the opposite direction. When a small amount of force is applied, when the force increases at some point, maximum static friction is reached. Here you have to apply a force in this direction to overcome the static friction. If you apply a more force, then the static friction it will come over, then the object it will start moving. But here you have to remember, static friction is nothing but the object it will possess friction when the object is at rest. That one, it is very, very important. Next, static friction examples. Following are the example of static friction: skiing against the snow, creating heat by rubbing both the hands together, table lamp resting on the table. These are the few examples of static friction. Next one, sliding friction. Sliding friction is defined as the resistance that is created between any two objects when they are sliding against each other. When two objects, when they will slide against each other, then it will create a friction. That friction we will call it as a sliding friction. When two objects, when they will be move on each other, then it will create a friction. That is nothing but sliding friction. Example of sliding friction are sliding of the block across the floor, two cards sliding against each other in a desk. Consider this is the sliding motion. Then sliding friction, it will be opposite to the direction of sliding motion. Sliding, always remember, when two objects, when they will be contact with each other, when they are in continuous motion, then it will create a friction. That is nothing but a sliding friction. Rolling friction. Rolling friction is defined as the force which resists the motion of a ball or a wheel is the weakest type of friction. Rolling friction is nothing but when the object, when it is in the form of a ball or wheel, when it is moving, then it will create a friction. That is nothing but a rolling friction. Example of rolling frictions are rolling of the log on the ground, wheels of the moving vehicle. These are the example of rolling friction. Rolling motion, it will be in this direction, then rolling friction, it will be opposite to the direction of rolling motion. What is fluid friction? Fluid friction is defined as the friction that exists between the layers of the fluid when they are moving relative to each other. When two layers of fluid, when they will be contact with each other, when they started moving, then it will create a friction. That friction we will call it as a fluid friction. Example of fluid frictions are the flow of ink and pens, then swimming. There are 5 laws of friction. They are: first one, the friction of the moving object is proportional and perpendicular to the normal force. Second one, the friction experienced by the object is dependent on the nature of surface it is in contact with. Third one, friction is independent of area of contact as long as there is an area of contact. Fourth one, kinetic friction is independent of velocity. Then the last one, the coefficient of static friction is greater than the coefficient of kinetic friction. Let us discuss the first law of friction in detail. The friction of the moving object is proportional and perpendicular to the normal force. Let us consider a cube. Then you have to place the cube on the ground. Then this cube, it will possess some mass. It will be equal to small m. This g, it is nothing but a earth gravitational force. Because of the earth gravitational force, this cube, it will exert a force on the ground. That force, it will be equal to F is equal to mg. Then this force, always it will be acts vertically downward. Then here, opposite to this force, one more force, it will acts on the object, it will vertically upward. That force we will call it as a normal force. Then here F is equal to mg. This force it will execute because of the earth gravitational force. G is nothing but gravitational constant. Here small m is the mass of this cube. Then F is equal to mg. This much force it will be act on the floor or ground. Then here capital F it will indicate the external force you have to apply on this cube. If you want to make this cube to move, then this external force capital F it will be more than this force, then only the object it will start moving. Otherwise it will not at all move, it will be at the same position. Then here small f it will indicate the frictional force. Here according to the friction first law, this frictional force is always perpendicular to the this normal force. Then the magnitude of this frictional force it will be equal to the magnitude of the normal force. That one you have to remember, that one very important. Frictional force is nothing but a opposing force. It will oppose the motion of the cube. If you apply a more external force, then only it will overcome the frictional force. Then only the cube it will start moving. Friction second law. The friction experienced by the object is dependent on the nature of the surface it is in contact with. Here this law states that the frictional force it will be depends upon the nature of the surface where the object it will be contact with the surface. Here consider the three cases. Here in the first case the surface of the object also smooth and the surface also it will be smooth. When both they will be contact with each other, then because of the smoothness of two surface the frictional force it will be less, because less interlocking between the surface. When less interlocking, then less frictional force. If you apply less force only, easily it can slide over each other because both the surface are smooth surface. Consider the second case. Here the object surface is rough surface and the floor is smooth. Then here the object it will possess more irregularities, as the smooth surface it will possess less irregularity. Then compared to first case, here the interlocking it will be more, therefore it will possess more friction compared to first case. Then you have to apply more pressure, otherwise more force to move the object. Here consider in this one only second case. Then here the surface is rough surface, the object is smooth one. Then here also the rough surface it has more irregularities than the smooth surface it has less irregularities. Both when they will come in contact, then they will get interlock. Compared to first case, here interlocking it will be more, then you have to apply more force to make the object to move on this surface. Then consider the third case. Here the surface of the object and the surface itself both are rough surface. When the two surface are rough surface, then irregularities it will be more, then interlocking it will be more compared to these two cases. Then in this case you have to apply more force to make the object to move, and here it will possess less frictional force. From this one you can conclude the frictional force it will depends upon the types of surface, whether it is a smooth surface or rough surface. If the surface is rough surface, then frictional force it will be more. If the surface is smooth surface, then the frictional force it will be less. As we move from bottom to top, the frictional force it will be increases. Third law of friction. Friction is independent of the area of contact as long as there is an area of contact. Frictional force are independent of area. Let us discuss with an example. Consider two cubes placed one above the other and placed on the floor. Then here consider same cubes you have to place next to each other and placed on the floor. Then here these cubes also it will possess some frictional force. These cubes also it will possess same frictional force. then mass of these two cubes and mass of these two cubes, it will be same mass, it will be same in both the cases. That is very, very important. Then here, therefore they will possess the same frictional force. Then if you make the cubes to move, then you have to apply 4 Newton of force, then the cubes it will move. Here in the both the case, the mass of the cube it will be same, then you have to apply same force to make the cubes to move. But here in this case, the cube it will cover this much area. In the second case, the cube it will cover this much area. Here the object how much area it will cover, that is not important. The mass of the object it will be important, whether the object it is covering less area, whether the object it is covering more area, that is not at all important. Then the mass of the object it will possess, that is very, very important. If the mass is same, then that object it will possess same frictional force. For this to be true, it is essential that all other variables be rigidly controlled. Therefore, frictional force are independent of area. Fourth law of friction, kinetic friction is independent of velocity. Consider an example here. If the object is moving with an velocity 5 meter per second, it will possess a same kinetic friction. To overcome this friction, you have to apply a force 2 Newton. Then consider same object. Then here both the case, the mass of the object it will be same. If the same object is moving with an velocity 20 meter per second, then here also the kinetic friction it will be same. To overcome the kinetic friction, here also you have to apply same force, that is 2 Newton. In both the case, the kinetic friction it will be same, whether the object is moving with velocity 5 meter per second or 20 meter per second. Therefore, frictional force are independent of speed or velocity, whether the object is moving with higher speed or lower speed, it will not depends. It will depends upon the mass of the object. The force of kinetic friction is same at 5 meter per second as it is for 20 meter per second. Fifth law of friction, the coefficient of static friction is greater than the coefficient of kinetic friction. Static friction is nothing but when the object is at rest, it will possess a friction. That friction is nothing but a static friction. Kinetic friction is nothing but when the object, when it is moving, it will possess a friction, that is kinetic friction. When the object is at rest, you know, irregularity of surface and object, both they will be contact with each other, then they will get interlocking it will be more when the object is at rest. To break this interlocking, you need more force. Therefore, you have to apply more force to make the object to move from rest to moving position. Here in the case of a kinetic friction, when the object already it is in motion, then here the object it will not get enough time to again interlocking. Then if you apply less force only, the object it will be in the state of a continuous motion. Therefore, force needed to start moving an object from rest is more than the force required to keep it moving. Let us mathematically express the law of friction. Already you know, frictional force is a opposing force. When two surface, when they will be contact with each other, it will exist a force. Therefore, frictional force is a contact force. Then normal force N is important here. Already explained, when two surface, when they will be contact with each other, then the surface of the object and surface both they will be contact. Then here the normal force it will be acting vertically upward. Then you know, because of the gravitational force, this object it is pulling vertically downward, then the normal force at the same time it will be acting vertically upward. Then two friction, one is static friction, another one is kinetic friction. In the case of a static friction, the frictional force it will be maximum. Let us express this one in mathematical form. F maximum it will be equal to mu s into n. Here the small f it will indicate the frictional force. The frictional force it will be maximum. Then mu s is nothing but a coefficient of static friction. N is the normal force. Then in the case of a kinetic friction, Fk, frictional force, then here mu k into n, mu k is the coefficient of kinetic friction. Let us discuss next one, increasing and reducing friction. Friction can be reduced or increased according to our needs. First one, way to increase the friction. Let us consider the example. Shoe soles are provided with grooves and spikes to increase friction. Similarly, tires have grooves and treads to move the vehicle without slipping. You can observe on shoe soles it contains so many grooves and spikes, otherwise some type of irregularities. On the tire also you can see some pattern of irregularities. It will follow a pattern. Then because of this pattern of irregularities, it will increase the friction. If the friction is less on the shoes or tires, when you are walking you can fall on the floor. Then when you are riding the vehicle or bike, you may slip on the road. To avoid this one, if you increase the friction, then easily you can walk on the floor when you wear the shoes. Here in the case of a tires, when you increase the friction, then it will reduce the slippering. Then you can easily ride the vehicle on the road. Brakes and braking system of cars and other vehicles are provided with rough surface to offer maximum friction. You can identify or you can observe brakes and braking system of cars and other vehicles. The surface is made up of a rough surface. You know, rough surface, it will create maximum irregularities. Then it will lead maximum friction. When the friction is more, when you apply the brake, immediately the vehicle it will stop. When we ride the vehicle, brake pads do not touch the wheels when the vehicle is running. Otherwise, when you are riding the vehicle without touching the brakes, then the brake pads do not touch the wheels. But when we press the brake lever, these pads arrest the motion of the rim due to friction. When you press the brake lever, then the pads they will touch each other, then they will create a friction. Because of the friction, it will stop the motion of the rim, then suddenly the vehicle it will stop. Next one, way to reduce friction using lubricants. The substance which are applied between the moving part of a machine so that they do not rub against each other are called lubricant. Lubricant is a substance you have to apply where the two surfaces they are touching each other, then it will reduce the friction. For example, oil, grease, soap, etc. By the application of lubricants, interlocking of the irregularities is avoided to a great extent. When the object come in contact with any surface, then because of the irregularities on both the surface, they will get interlocked. If you apply a lubricant on both the surface, then where the surface exactly where there will be contact, if you apply a lubricant, then interlocking of the irregularities it will be avoided. When the interlocking is avoided, then frictional force automatically it will be reduces. In this way, you can reduce the friction. Using powder example, sprinkling talcum powder on the carom board. Because of the powder, the friction it will be reduced. Then easily the pan it will move on the board. Using wheel, roller and ball bearings. By using wheel, roller and ball bearings, we can reduce the friction. Wheels and rollers reduce friction. When you are having wheels and rollers on the surface of the object, then the object when comes in contact with the floor, then it will reduce the interlocking between the object surface and the floor surface. When the interlocking is reduced, automatically the friction it will reduce. Then the object it can move very smoothly on the surface. Therefore, wheels and rollers ensure fast motion and reduce friction. For this reason, modern day luggage is provided with wheel and rollers. If using this one, you can carry a heavy luggage from one place to another place. All vehicles have wheels and brakes, which helps in controlling speed and even stopping it. Almost all the vehicles you have brakes. Because of the brake, you can control the speed or velocity of the vehicle. Even you can stop the vehicle if you apply the brake properly. Ball bearings. Friction causes wear and tear in machines that can be reduced by the use of ball bearings. For example, ball bearings are used in between the hubs and axles of ceiling fans and bicycle. You can observe ball bearing in ceiling fan and also bicycle also. It will help to damage the instrument. Let us discuss application of friction. Friction finds application when matchsticks are ignited. If you want to ignite a matchstick, then you have to rub on a surface. Then it will get ignited. Motion of piston in a cylinder is an application of friction. It is possible to write on books and board as there is a friction between the pen and the board. Due to the friction only, the ink it will get stick on the books and board. Thanks for listening my class. Send me your valuable feedback.